Today we are going to talk about the internal structures of the cerebellum and brainstem as well as the safe entry zones and surgical approaches of the brainstem. Let's go through the cerebellum first. The cerebellar white matter is formed by three cerebellar peduncles: superior, middle, and inferior. The largest one is the middle cerebellar peduncle, which connects the cerebellum with the pons. The transverse pontine fibers collect together to form the middle cerebellar peduncle at the level of the trigeminal nerve. The inferior cerebellar peduncle, which is a connection between the cerebellum and spinal cord, travels between the middle and superior cerebellar peduncles. This is a posterior view. The inferior cerebellar peduncle reaches the cerebellar worms by passing above the dentate nucleus. Damage to the inferior and middle cerebellar peduncles may result in ipsilateral ataxia. Finally, the superior cerebellar peduncle, a connection between the cerebellum and the thalamus, arises from the dentate nucleus and ascends up to the thalamus. At the level of the midbrain, some fibers of the superior cerebellar peduncle decussate to form the capsule of the red nucleus before reaching the thalamus. Damage to the superior cerebellar peduncle may cause contralateral cerebellar ataxia and tremor. The superior cerebellar peduncle forms the superior half of the lateral wall of the fourth ventricle, and the inferior cerebellar peduncle forms the inferior half of the lateral wall of the fourth ventricle. We are looking at the cerebellum from posterior. The uvula, pyramid, and nodule are located on the midline, whereas the peridentate nuclei are located next to the midline on each side. The dentate nucleus is the major outflow of the cerebellum. Here, one can see the forming of the lateral wall of the superior half of the fourth ventricle by the superior cerebellar peduncles. The posterior view, when the dentate nucleus is damaged, equilibratory disturbances often accompanied by intention tremor during voluntary movements of the extremities can be seen. During the transforming approach, splitting the inferior portion of the vermis may also play a role in cerebellar mutism. The dentate nucleus is located at the superior medial position in the cerebellar hemisphere. After looking at the cerebellum, let's move on to the internal anatomy and safe entry zones of the brainstem. The brainstem is divided into midbrain, pons, and medulla. The medial lemniscus, which is related with proprioception and vibration of sense, travels through the brainstem and divides it into dorsal and ventral parts. The medial lemniscus is the most tolerant fiber tract for surgical manipulation in the brainstem. The corticospinal tract can also be seen at all levels of the brainstem. In front of the medial lemniscus is the ventral brainstem. The ventral part of the midbrain and pons contains the corticospinal, corticobulbar, and corticopontine tracts. The caudal medulla contains only the corticospinal tract. In the midbrain, the corticospinal and corticobulbar tracts are located in the mid portion of the cerebellar peduncle. In the pons, the corticospinal tract travels anteromedially. We are looking from posterior. Behind the medial lemniscus is the dorsal brainstem. The medial longitudinal fasciculus extends from the midbrain to the upper spinal cord next to the midline and interconnects the nucleus of the oculomotor, trochlear, and abducens nerves to coordinate ocular movements. The lesion of the MLF produces intranuclear ophthalmoplegia, which is called vertical gaze palsy. The central tegmental tract connects the inferior olivar nucleus with the red nucleus by passing through the facial colliculus. The trigeminal nerve gives off two tracts, which are an ascending trigeminal mesencephalic tract and descending trigeminal spinal tract. Damage to these trigeminal tracts may cause some loss of sensation. The MLF travels next to the midline. The central tegmental tract is a part of the extrapyramidal system, and its damage may result in intentional tremor or nystagmus. The central segmental and trigeminal mesencephalic tracts are positioned between the superior cerebellar peduncle laterally and sulcus limigens medially. After looking at the ventral and dorsal neurocortical fiber tracts of the brainstem, we can go through the safe entry zones. The safe entry zones in the midbrain that we will discuss are the pericoculomotor zone, used for lesions located in the ventral midbrain, the supra and infracollicular areas for lesions in the dorsal midbrain, and the lateral mesencephalic sulcus for both ventral and dorsal located lesions. In the pons, the peritrigeminal zone is used for ventral, and the supra and infrafacial collicular approaches for dorsal pontine lesions. In the medulla, the anterolateral, post-olivary, and dorsal medullary sulci have been proposed as safe entry zones. The surgical target area for reaching the pericoculomotor zone is the ventral surface of the midbrain. The pericoculomotor zone is bordered by the posterior cerebral artery superiorly and the superior cerebellar artery inferiorly. The transcranial roads by the terional or orbitozygomatic approaches can be used to reach the pericoculomotor zone. On the left side, the uncus and oculomotor nerve can be seen here, and the posterior clinoid and basilar artery also seen here. The pericoculomotor approach is directed through the frontoponine fibers and is bordered medially by the exit point of the oculomotor nerve and laterally by the medial edge of the corticospinal tract. The frontoponine fibers were removed to expose the medial lemniscus, which is the border between the ventral and dorsal midbrain. The corticospinal tract is the lateral limit of this exposure. An entry through the pericoculomotor zone can reach the ventral midbrain, which is in front of the medial lemniscus, or dorsal midbrain, which is behind the medial lemniscus. Avoiding damage to the intramesencephalic segment of the oculomotor nerve is important. This segment arises from the oculomotor nucleus and passes medial and inside the red nucleus to exit the midbrain through the intrapeninsular fossa. Another entry zone in the midbrain is the lateral mesencephalic sulcus, which is positioned on the dorsolateral surface of the midbrain. The lateral mesencephalic sulcus is accessible through the subtemporal approach. This is a right subtemporal view, and tentorium is right here. The lateral mesencephalic vein runs into the lateral mesencephalic sulcus. Non-complications in this approach are the ophthalmoparesis due to manipulation of the cranial nerves 3 and 4, and the venous infarction caused by damage to the vein of Lappe complex. The lateral mesencephalic sulcus can also be reached by the lateral supracerebellar infratemporal approach. The sulcus runs on the dorsolateral surface of the midbrain and extends from the pontomesencephalic sulcus inferiorly and medial geniculate body superiorly. The sulcus also corresponds to ventral surface of the medial lemniscus. Critical structures at risk in this area are the corticospinal tract in the ventral midbrain and the red oculomotor and trochlear nuclei in the dorsal midbrain. Entry at the right angle to the tactile surface encounters the red nucleus, while entry at a 45-degree angle reaches the medial lemniscus. The depth of the red nucleus from the lateral mesencephalic sulcus averaged 5 mm. The surgical target area for the pericollicular entry zones is the dorsal surface of the midbrain. The pericollicular entry zones can be reached by way of the supracerebellar infratemporal approach, which also exposes the pineal gland, superior and inferior colliculi. Transverse incisions are made just above or below the colliculi depending on the location of lesions. The nuclei of the superior and inferior colliculi are located just deep to the surface. The superior colliculus is involved in the reflex movement of eyes and head, and inferior colliculus involved in the auditory system. The deep structure is the red nucleus in the dorsal midbrain that extends up from the mid-level of the inferior colliculus. Inferior dissection, bilateral red nuclei and decusation of the superior cerebellar peduncle, which is positioned at the level of the inferior colliculus, have been exposed. The central tegmental tract runs just ventral to the trigeminal mesencephalic tract. The oculomotor and trochlear nuclei and medial longitudinal fasciculus are located ventral to the aqueduct. For this reason, the aqueduct is an important landmark for avoiding damage to these structures. This lateral view demonstrates that the oculomotor and trochlear nuclei are positioned ventral to the aqueduct. The intramesencephalic segment of the oculomotor nerve passes through and medial to the red nucleus to exit through the interpennicular fossa. The red nucleus extends up from the mid-level of the inferior colliculus to the lateral wall of the third ventricle. The subthalamic nucleus is located ventrolateral and the medial lemniscus is located lateral to the red nucleus. Here is the lateral mesencephalic sulcus, which corresponds to the most lateral edge of the medial lemniscus. This illustration shows the surgical target area for reaching the peritrigeminal zone for removal of the ventral pontine lesions. Using the retrosigmoid approach in reaching the peritrigeminal zone, one can see the trigeminal and facial nerves here. The anterior petrosectomy, also called as Kawase approach, can also be used for exposure of the peritrigeminal entry zone. The trigeminal and the facial nerves can be seen. The peritrigeminal zone incision is made between the trigeminal and facial nerves. Structures at risk are the intrapontine segment of the abducens and facial nerves inferiorly, intrapontine segment of the trigeminal nerve superiorly, trigeminal spinal tract, trigeminal motor and mean sensory nuclei posterior medially, and corticospinal tract anterior medially. The surgical target area for dorsal pontine lesions is the floor of the fourth ventricle. The median suboccipital approach can be used to reach the floor of the fourth ventricle. The most important structure to avoid in this area is the facial colliculus. 37% of facial colliculi did not form a distinctive prominence in the floor. The facial colliculus, which is formed by the abducens nucleus and intrapontine segment of the facial nerve, is also the most important landmark on the floor of the fourth ventricle. The intrapontine segment of the facial nerve arises from the facial nucleus, courses backward to reach the floor, curves around the abducens nucleus, and then runs forward to exit the brainstem. At the same time, seen that the intrapontine segment of the abducens nerve arises from the abducens nucleus and runs forward to exit the brainstem. On the floor, the superior fovea has a triangular shape. Its superolateral edge is formed by the superior cerebellar peduncle, its inferolateral edge formed by the vestibular area, and its medial base formed by the sulcus limitans. The lateral apex of the superior fovea triangle is an important landmark for the upper edge of the facial colliculus in case where the prominence of the facial colliculus is not well defined. Also, the trigeminal motor nucleus is located deep to the superolateral edge of this triangle. For dorsal pontine lesions, the entry zones above and below the facial colliculus are used. The suprafacial approach is bordered superiorly by the frenulum valley containing the trochlear nerve, inferiorly by the facial colliculus, medially by the medial longitudinal fasciculus, and laterally by the sulcus limitans, which is situated just medial to the trigeminal nuclei, trigeminal mesencephalic, and central tegmental tracts. The infrafacial approach is bordered by the facial colliculus superiorly, hypoglossal triangle inferiorly, medial longitudinal fasciculus medially, and facial nucleus together with nucleus ambiguus, which are the same corneal plane laterally. The rostrocaudal length of the infrafacial entry zone is the same as the distance between the upper and lower borders of the lateral recess. The surgical target area for ventral medullary lesions has been shown here. The bilateral approach is used to reach the anterolateral and posterior sulci. The longitudinal incisions are made between the hypoglossal nerve and rootlets of the C1 in the anterolateral sulcus or in the posterior sulcus. The critical structure in this approach through the anterolateral sulcus is the corticospinal tract. The nucleus ambiguus must be taken into account when entering through the post-Olivar sulcus. The dorsal medullary sulci, including the posterior median, intermediate, and lateral sulci, are proposed as safe entry zones. The median suboccipital approach can be used to reach these sulci.